Good morning, good afternoon, good evening, depending where you are watching us from. This is Casino Digital Tech Engineering Services. In this video, I'm going to show us a project I designed. The name of the project is Phototherapy Light. It was requested by a student, a final year student in the high institution. And the phototherapy light is a medical equipment used in the hospital and also in the laboratory. But before we go further, I want to show us the block diagram of the phototherapy light. You cannot design a circuit we cannot design a system without first having your block diagram, and from that you get your schematic diagram before you go to the real hardware connections. If you look at this place, block diagram of phototherapy light, we have a particular, in this block diagram we have a 6-unit block unit. The number 1 is AC main power supply, number 2 is control unit, number 3 is backup battery, number 4 is solar power, number 5 is light intensity control, while the number 6 is blue LED light. And you know that phototherapy light is always blue. This is the block diagram. Let me explain how they are connected. From looking at the block diagram, you look at the arrow, how the arrow moves. The power supply moves to control unit, solar power to control unit, backup battery goes into backup battery, return to control unit, from control unit, light intensity control, and to blue LED light. Here we have a backup battery, and the light intensity control is permanently connected to the backup battery, and this backup battery is a rechargeable battery. So we have a double source for charging the battery. First source is the AC power supply, second one is the solar power. Then looking at the control unit determines the one that charges the battery at a particular time. When there is no light, the solar power charges the battery. The solar power output is connected to the normally close of the relay. From the same normally close to reasonable contact, and from that reasonable contact to the battery backup. So when the relay is not biased, the solar power is directly connected to the battery backup and discharging the battery. Once NEPA brings light, the AC power source will energize the coil of the relay, and we now transfer the normally closed, the reasonable contact, from normally closed to normally open, at the same time transferring the battery from the solar terminal to the AC power source terminal, and the AC power source will be charging the battery. When the NEPA takes the light again, it will automatically return back to the solar power. That is what the control unit does. It helps to move the battery from solar to the AC power supply. Then from the battery, it returns to the control unit, then down to the light intensity control. What happens in this light intensity control is that we design it using a 55 timer IC. It's a very versatile IC. Any technician we know about it, electronics technician we know about it, is very versatile. And we configure it in acetable multi-vibrator. We use it to increase the intensity of the LED, that is to increase the brightness and to reduce it. That's what the light intensity does. We can change the intensity, we can change the brightness, we can high it or we reduce it. This is what the light intensity does. And the AC power supply, we step down the 220 volts with a step down transformer, step it down to 12 volts, rectify it, filter out, then we have a pure DC. We put indicator light to show that there is light on the AC power source. Then from there we control the relay of the control unit using the AC power. So it is only the AC that will determine whether the relay will close or not. That is what happens on the block diagram. Everything is connected together. As the arrow shows, that is the movement, and that is how current flows from one unit to the other, from one section to the next section. When you look at the battery set or at the battery backup, you will discover that it has an outgoing arrow and incoming arrow. Means that it store charges, it brings out light, power again to power the LED. So this is the pure block diagram of a therapy light. Okay, having looked at the block diagram, we will now look at the circuit and how we design the circuit using Pro Tools. Okay, let's now go to the circuit diagram. Open our Pro Tools. This is the Pro Tools interface. It's the electronics software simulation. We go to our programs, it's our library. Start selecting the components that we need for this project. All the components that we characterize, all the units of the block diagram, as explained earlier on. We are going to select all the we are going to select all the components, the bridge rectifier, our capacitors, our diode, all the components that we need to get this work done. We start selecting all of them. Select the solar panel. We want to draw the complete schematic diagram. The complete schematic diagram on the Pro Tools. After the drawing, we start the hardware construction. Select all the components that we need. I have timer for the intensity control units. We need to select all the components. Control units. Select our ceramic capacitor, that is 0.01 microfarad. We also select 100 nanofarad. Then all the components, like I told us earlier on, we are going to the control unit and the intensity control unit. More especially the intensity control unit was designed around 5510, and if you have not known anything about 5510, it's a versatile integrated circuit IC that can be used to do so many things when it comes to electronics design, and you can configure it to operate in three basic forms: the acetable, monosetable, and bisetable. But in this our project, we are going to construct it to operate in acetable multivibration. That means it will be going and coming, that is high and low, high and low, high and low at interval. By this method, we will be able to increase the brightness of our LED and reduce it using a potentiometer. Like you are seeing it here, we are selecting it now. Using a potentiometer, do this selection, increase the brightness, reduce the blackness, everything. This is a very good project. Okay, we are done with the selection of the components. What we start now is to start making the schematic design. First of all, place our step down transformer 220 to the 12 volts, place our bridge rectifier, that is bridge diode, and making the connection, connecting the 12 volts terminal of the transformer to the sine wave pin of the bridge rectifier. Then what next do? We will now connect ground. Okay, we've connected the ground. Okay, the connection continues. What next we are going to place now is capacitor. Like I told us when I was explaining the block diagram, after rectification, if you don't filter, there are chances that you are not working with perfect pure DC, because there are some ripples that will be escaping from the rectification stage. But with this capacitor now, you have been able to filter out the whole ripples that will not be able to trap down at the rectification stage. Okay, we've connected the capacitor. What next? We put our resistor for indicator, that is 1K resistor, to limit the current that will flow in the LED that we're going to connect there. Okay, you see it? Okay, that's the indicator LED to show when power enters from the AC side. Once there is power from the AC power side, this LED will come up. Okay, we connect our relay. This place now, we have left the AC power supply stage and now in the control unit. Like I told us, in the control unit, what we have there is our diode and relay. We have 4 basic type of relay: single pole, double throw, single pole, double pole, double throw, single pole, double throw, single pole, single throw. 4 basic type of relay, that's what we have. But in this project, we are making use of single pole, double throw, 1 reasonable contact, 1 normally open, 1 normally close. It's either it's on the normally close or on the normally open. That's the double throw. But the reasonable contact that moves is 1. That's what we call it, single pole, double throw. Okay. The DC that we got from the rectified stage from the power supply is connected to the normally open of the relay, so that when NEPA brings light, it will transfer the battery. You can see the battery is being connected to what is it called? The battery is being connected to the reasonable contact of the relay, positive terminal to the load, then the other one to the ground for reasonable contact. Okay, so drawing and saving. Then next, what we have to do here next, we are done with the control line. The next circuit we are going to enter now is what is it called? The solar part. The reason for that diode there is to protect the battery and also the solar panel. If you don't do it that way, at night when there is no sunlight, the charges that was stored in the battery will be returning back to the solar panel. But with that diode there, that is 15408, with the help of that diode there, once it's night and there is no sunlight, the charges stored in the battery will not come back to the solar panel. That is what the diode is. They are all inside the control unit, like I explained on the block diagram. Okay, the next unit we want to enter now is now the density control unit. Density control unit. That is the unit we are going to enter now. Okay, we drop our 5F timer. I told us, for the people that don't know anything about 5F timer, you can go to the double the data sheet of the 5F timer to help you connect pin 4 and pin 8 to VCC. Pin 8 is the VCC pin, while pin 4 is the reset. But because we are using it as we have configured it to work as a stable multi-vibrator, we don't need to leave the reset button, the reset pin floating or connecting reset button there. Tag it up to VCC. Then pin 2 is the trigger pin, while pin 6 is the threshold. And because also we are configuring it to work as a stable multi-vibrator, what do we do again? Tie pin 2 to pin 6. So whenever you are making a design or you come across any circuits of this nature, just look at that 5/5 timer. Look at the configuration of pin 4 and pin 8, pin 2 and pin 6. The configuration you have there will tell you the mode that the 5/5 timer is configured to work as. Okay, we are now designing the density terminal. With that variable resistor there, with that potentiometer there, when you are varying the potentiometer, the density of the light, the brightness of the light will be increasing and decreasing at the interval. What happens there again is that we need to pull up the pin 7, that is the control pin of the 5/5 timer. We need to pull it up to VCC using 10K. Why we pull up to VCC is because of what? We are using it here as a brightness control, or you can call it a auto control. If it is normal standard stable multi-vibrator, we bias pin 6 and pin 7 with a voltage divider resistor and then pull it up to VCC, so that when it charge, because that pin the pin 7 is the discharge pin, while it charge from R2, that is the resistor that is connected directly to pin 6, it will be discharged. While it's charged from the resistor that is connected to pin 6 and pin 7, then with the one that pulls off pin 7 to VCC, it will discharge from the one that is connected to from pin 6 to discharge pin. I don't know if I'm making sense for what I'm talking about, but just capture what is happening here. In our next tutorial, we are going to explain in details configurations of 5/5 timer. Just capture what we are doing here. Do it the same way we did it here. In our next tutorial, we'll be explaining in fullness the configuration of 5/5 timer and how it operates. What we are now designing is the LED unit. We are just connecting the LEDs, connect it 3 in series, and then 5 of them in parallel. In series, then 5 of them in parallel. That's what we are doing. This is the customized design. If you have come across any other therapy light, we discover that it is only being powered with AC. Once there is no light, nothing happens. Awesome, it's powered by solar. Once it's night, nothing happens. But with this battery backup, even when there is no light, when there is no solar, sunlight, when there is no NEPA light, the backup battery will still serve you. And also, when you are running it on battery, you don't need to leave the intensity very bright so that it will allow the system to last long. So with this particular circuit now, you can be able to set the intensity of the light so that it will help to conserve your charges that you have in the battery. You get it? Without this intensity control unit, the system will still work perfectly very well. But when it's running on the backup battery, we need to be able to control the brightness of the LED so that we will be able, so that the battery, the charges we store in the battery during the daytime, or maybe during the NEPA light was on, during the time that the NEPA light was on, so that it will help and stay much longer for us. Have you seen the reason why we introduced that light intensity control? To help us. Okay, we are done with the complete circuit. This is the complete circuit of the Phototherapy Light. The complete circuit. This is what